Okay, calculating F over Q2, we simply take the force, which we've approximated, and I didn't mention it in the previous, but this is a very rough approximation, 0.005 newtons times I, 0.004 newtons times J, the force that we got using the two charges that were originally postulated, divided by the 6 microcoulombs at the point of the second charge at the second point. And we do that division, we get 8.3 newtons per coulomb times I, plus 6.7 newtons per coulomb times J. So there's your force divided by the charge. If we multiply this then by any charge that we want to put at point 2, if we want to change Q2, we just have to multiply this by whatever that charge is. And you should understand deeply why that's the case, just in terms of the basic arithmetic and algebra of the situation and the proportionalities involved, etc. Okay, so force divided by Q2, that's your force per unit charge at 7 meters, 5 meters, due to the charge 2 microcoulombs at -4 meters, -3 meters. That's what this represents. Multiplied by the 3 microcoulombs that we now want to put there, and this is just verifying the calculation we had before. Recall that we calculated for the 3 microcoulombs based on this, 3 microcoulombs being half of the 6 microcoulombs that we originally had, the Q2. We got the 0.00025 newtons I, 0.002 newtons times J. Well, if we multiply F over Q2 by the 3 microcoulombs, which is the new charge we want to put at 7 meters, 5 meters, we get the same thing that we got before. And if we wanted to put a -3 microcoulombs here, we'd get a negative here and a negative here. So we get the force on the charge at the 7 meter, 5 meter position. Okay, so this F over Q2 thing we call the electric field. E equals F over Q2. It's the electric field at this point due to this charge located at this point. Okay, so in general, we're going to say F of xy equals Q times E of xy, where E of xy is the electric field at point xy. F of xy is the force felt by the charge Q. We multiply Q times E. So obviously, if E equals F over Q2, F equals Q2 times E. And we drop the 2 because now we're talking generally about this thing called an electric field that we've calculated in one way or another. We don't have a Q1 and a Q2. Once we get the expression for the electric field, we just multiply that by the charge, we get the force. We can modify our Coulomb's law. Instead of K Q1 Q2 over R squared, the electric field is just K times Q over R squared. That's the field due to the charge Q. It's the field at XY, the field calculated at point XY due to the charge Q at whatever point it's located. And you'll see this in your text, and you should understand it much better having seen it here.